So let's start with AI terms and terminologies. So these terms would help you understand the basic terminologies that are behind AI. That would be very much helpful in understanding AI Agent Studio. It would be helpful in communicating to your developers, your or other persons that are working in AI Agent Studio. So let's just start with that. So the first term would be artificial intelligence. So what is artificial intelligence? So artificial intelligence is a broad term. It is the intelligence of a machine, a machine that tries to think like a human. So that's called artificial intelligence. You all of you might know that. Then comes accuracy. So accuracy is a metric that measures how correctly a model predicts outcomes compared to the actual results. So a higher accuracy means better, a lower accuracy means it's not that much good. So we always aim for higher accuracy. So training data. So all of us know that AI is trained on data. We train AI on large sets of data, and based on the quality and the quantity of the data, the accuracy goes higher and higher. If you provide large amount of data of multiple scenarios covering the edge cases, then the accuracy would be high. So data can be labeled or unlabeled. Label means you give a picture of a cat and you label that this is a cat. So that's called label data. And unlabeled data, we will not label the images or data as anything. The agent itself would try, the model would itself try to understand the similarities between the images and try to group similar images together. So next comes machine learning. Machine learning is a subset of AI. So is it AI? Yes, but we have other aspects of AI other than machine learning too. So machine learning is when a model tries to learn on its own. So in most cases, this is used for forecasting. So they make better predictions. So if we give ChatGPT some data and if we ask for it to predict, example, if you are driving your car every day and you have prepared the cost of driving your car across 6 months, and you give that data to ChatGPT and you ask ChatGPT how much would it cost to run my car in the 7th month, it would obviously give a good guess, and the number would also be pretty close to what might be your 7th month expense. But on larger financial data or larger numbers, this might not be the best approach because large language models are not good at predictions. So there we use machine learning. Now algorithms. So algorithm, all of us know what algorithms are. It's a set of instructions. When it comes to AI, it's a set of mathematical instructions. So that's the base of everything. Next comes models. Now we know that algorithm powers everything from voice assistants, self-driving cars, even the code that we write in any language, it always follows a certain algorithm. It follows a step-by-step pattern. So when an AI model, what an AI model is, it is the result of training an algorithm on data. All of us know, all of us use ChatGPT. When we use ChatGPT, we can see the model there. ChatGPT has models 4, 5, 4.0, ChatGPT Go, like that. So all of those are models. Think of it as a trained brain. It already has access to a large volume of data. So we can ask anything to it within those boundaries, and it would give us those answers. So models are often parameterized by the amount of data that is used to train it. So it's called parameters. So each models would have the number of parameters that is used to train it along with that. If you search for the model's details, you will always get that. For example, ChatGPT's latest model, they have not officially said anything, but sources say it's over a trillion. Over trillion parameters have been used to train that. We have Meta Llama 70B trained on 70 billion. So these number of tokens are used to train these models. So I used the word token here. We'll get to know what token is in the coming slides. So we understood what AI is. We understood what ML is. Now let's understand what generative AI is. So an AI that generates something, so generates a text, generates a video, generates a music, a voice note. So that's called generative AI. So one thing that some people get confused with is multimodal AI. Multimodal AI is also like the same principle. So a generative AI, one of the main examples of generative AI is ChatGPT that uh, has other examples like Metalama. All of these have a GUI or a user interface that the user uses, and it also has APIs in the backend. So when we are developers and we are trying to use these APIs, we should know certain parameters that goes with this AI that should be used to tweak the output that we receive from this generative AI. Okay, now let's go to NLP. So NLP is natural language processing. So it's just like Siri, Google Assistant, all of those understand what the human says. It understands our speech and it changes the speech to text and it gives the text to an LLM. So the LLM can understand what we said and then it gives us an output. So the AI is also a big part of here. And next comes prompt. Now, prompt is what that we use to communicate to an AI agent. AI agent, let it be a generative AI, let it be a LLM. So we want to write a code. We want to write a Python code to find the sys date, find the current date. So we ask ChatGPT, hey ChatGPT, write me a Python code to get the current date. So that text is called prompt. So when we are creating AI agents using Oracle AI Agent Studio, this is the most important part. I can't emphasize it enough. Prompting is one of the most important part that comes under Oracle AI Agent Studio. If you can write good prompts, then 25% of your headaches is gone. Okay. Now I brushed upon the topic multimodal AI. So multimodal modal means types of data. So we have different types of data like text, images, PDFs, audios, table, everything. So if an AI agent or an AI model can understand these different types of data, it can be called multimodal. Next comes hallucination. So when an AI does not have a proper set of data, or in some cases, even when it has a proper set of data, it still gives us the wrong output. So some of you might know the 2 R's of strawberry. So when we used to ask ChatGPT how many R, the letter R's are present in the word strawberry, it used to say two. Now it's fixed. But that was the clear example of hallucination. Now, the one example that still happens is the next year problem. We can go to the slide and we can see what happens in that issue. If we go here, let's see. I have asked ChatGPT, answer in one word for the next question. Is the next year 2027? No. See, I asked it in asked it the multiple questions. Is this year 2026? Yes. What is the next year? The next year is 2027. So is the next year 2027? Yes. See, the same ChatGPT, the same user, but two different answers. So we can't do anything about ChatGPT being wrong, but we can improve our prompts. You could see how I asked those two questions differently, and the ChatGPT gave me two different answers. One of them was right and one of them was wrong. Okay, next comes fine tuning. Now, fine tuning means the process of taking a pre-trained machine learning model, such as an LLM or a foundation model, and training it on a smaller task. For example, if you have a model that is used to extract data from images. For example, you have a client and the client wants to extract data from invoices. So you have the PDF invoices or you have the image invoices and you want to extract the data from those images. So you have an AI model that is used to extract data from all kinds of PDFs. But you want this to work 100% of time in the invoices for the invoices. So you want to fine tune that model so that it understands that the date coming here is the invoice date, that there's a number here, it should be the invoice number. There's a currency here, it should be the invoice currency. There's an amount here, it should be the invoice amount, like that. So we adapt the AI agent for a specific use case or a single domain. So that's called fine tuning. So it is used to handle a narrower problem by training the model on the necessary data. Now let's go to RAG. So RAG, we have the option to include RAG in AI Agent Studio. So what is RAG? RAG is Retrieval Augmented Generation. Imagine all of us have uh, different kinds of documents in our workplace, in our personal life, anything. So um, let's take the general example of an HR policy. So in HR policy, almost every 99.9% of the companies have an HR policy, and people have questions from those HR policies. Instead of pinging your HR, you could ping a chatbot. You could just go to a chatbot and you could ask the chatbot, what is the leave policy in my company or in my organization? So the chatbot will reply to you from that document. So it has the document as its source. So imagine that document, you can't share that document to the public. You have certain risk. Let it be a financial data. You don't want that document to get leaked. So you have to have the control of that document. So what will you do? How will you create an AI agent or a chatbot from a document that you don't want to share to the public, that you don't want to upload to a cloud? How will you do that? So that's where RAG comes in. So what RAG does is that it takes a document, it vectorizes it. We will come to what vectorization is. We'll come to it in the next slide. It vectorizes it, it stores it in a DB, and whenever you ask a question from the document, it goes to that database where you have stored this vectorized data, and it will fetch those. If you ask for leave policy, it will fetch all the information related to leave policy from your document, and it will give that to an LLM, and it will frame an answer from the bunch of words that was given to it by the RAG. So that's basically conversion of a document to a chatbot. That's being done here, retrieval augmented generation. Now, earlier we talked about using APIs for ChatGPT. You understand that we have a user interface, but we can use these LLMs within codes. So for example, within Python, for example, let's come to Oracle's ecosystem. We can use LLMs within Apex. Let's say within PL SQL, we can call these LLMs within PL SQL, and you can do some operations there. So how will you get these LLMs to your code? How will you transfer data between them? So that's where APIs come in. So in order to get what you want exactly, you have certain parameters for the APIs. So that's where this temperature, top P, top K, those come in. So temperature, it's a parameter in a language model that controls randomness in text generation. Lower values make the output more deterministic, while higher values produce more creative and varied responses. Example, you want to write an essay. An essay should be more creative and more varied. So you put the temperature as a higher value, and you don't want the data to change. You want it as a constant. In that case, you put the temperature as a lower value, preferably 0 or 0.1, like that. When do you want this constant output from an LLM? Example, you are you give you are using an LLM to create an email, and it's an automated process. You want the email to be sent every time, and you want the emails to be similar in every case. If you send one this week and you send one the next week, it should be similar, and the data should be formatted in a similar way. So in those cases, we can use the temperature as a lower value, and for creative examples, you want to put the temperature as a higher value. Now, now let's go to top K. Now top K, what top K does is that when a model has to choose a bunch of tokens, it sets a number. Choose the 10 most likely tokens. Choose the 50 most likely tokens. That that control is being told by the top k parameter. Let's just go to the next slide and see what top p is. So top p, instead of choosing an n number of words or tokens, what happens is that it takes n number of words or tokens whose probability adds up to the top p. The p stands for the probability. For if p equals zero point 0.9, the model considers only the most likely words that together add up to 90% probability. So some of you might have some questions on the last two terms that I said. I have introduced two new terms called probability and tokens over here. So what does probability have to do with AI agents or with AI in general? And what are tokens? So humans understand text using letters or words. An LLM does not do that. LLM understands text based on tokens. A token can be a word, but a word can be a multiple tokens. I think you get what I mean. So, for example, uh, if you have the always we use the same example everywhere. Hello world. So we have hello. The hello would be one token. We'll have a comma. Then, if the comma is there, the comma would be one token, and we'll have space and world. Then the space along with the world would be one token. So the space gets added to the world, and that would account to one token. So in some cases, token a token is a single word, and in some cases, a word can be cut into multiple tokens. I hope that's clear. Now, where this probability comes? So basically, what any LLM does is that it predicts what the next word is. So if you have trained an AI model on the sentence, this is a cat. So after this and is comes a cat. So the probability that a and cat should come should be 90 or 100%. So that's the probability. So we control the probability of the words coming using this top p and the top k. So top k limits the model to choosing from only k most likely next tokens. For example, this is a and we give 5. So this is a cat, dog, book, bag, and ball. So those are the 5 examples. So we limit it to those 5, and then the rest of them will not get picked up. So top P, what does top P mean? Top P means that out of those 5 words, it is not just selecting the 5 words, it will select the 5 words whose probabilities rank up to the P value. So if P is 90, the probabilities of those 5 words should add up to 90. So that's how top P works. Now embedding. So we understood what RAG is. So embedding is representing data, any data, let it be words, images, anything. It is represented using numbers so that the machine can understand what is behind these words, these images, these videos, these audios, anything. So let's take the human understandable format. So let's just assume that there is a word called an apple. So what embedding does is that embedding assigns x, y, and z coordinates for a three-dimensional space for the word apple, and it plots this in a graph so that we get the relative position in 3 dimension for every words that are present in the universe. So that is being done for vectorization and embedding. So I have an example over here. So for embedding, for since we humans cannot understand anything beyond 3 dimensions, I have stuck to the 3 dimensional figure over here. Let it be x, y, and z coordinates, and we are plotting words over here. See, we have these are dimensions like x coordinate, y coordinate, and z coordinates. In a real life scenario, it has much more dimensions. It is see in the example here, it's shown as 300 dimensions. A human brain cannot process how 300 dimensions looks like. So for understanding here, we have taken this. If you could see here, see cat is this small dot over here, and kitten is placed next to it, and a dog is relatively close to it, but a wolf is further than from it. And if you see, we have apple, which is completely on a different plane. So what you should understand from this picture is that who makes this graph? This is done by a previously trained model that understands where to place each words. So we don't have to do nothing about that. So how is this placed? It is placed by meaning. Meaning means cat and kitten are related, so say they should come together. Cat and dog are domestic animals, so they should come together, but not as close as cat and kitten. Now, wolf is also an animal, but it's not a domestic animal, so it should be farther from these. So that's how these data are represented in three-dimensional space. For your understanding, it can be 300 or 640 or any number of dimensions. So when we use the same principle for our HR document or HR policy, what happens is that this area would be our leave policy. And when the user asks a question about leave policy, all the data surrounding this area would be fetched and fed to an LLM. So your whole document does not get compromised. Some words here and there just gets transferred to the LLM, and the LLM can make a human intelligible format from those words, and it can give you an output. So that's what LLM does. If you are skeptical about giving it to an ChatGPT or something like that, there are options to buy LLMs, keep it in-house, host it yourself. You can use that, so even that data will not go anywhere. It would be safely within yourself. So that's where embedding comes in. The process of searching in a embedded or vectorized data is called semantic search. Semantic search means searching by meaning, not just searching by keywords. So there's one interesting example that I want to share with you all, which comes under these embedding, vectorization, and the semantic search. So all of us know mathematical formulas that 1 plus 1 equals 2, like that. So we can't perform mathematical operations on words, like, right? But in this scenario, we can do. So king minus woman would be queen. So those kind of actions are possible when we transform these words, text, or anything into vectors, and we put it in a graph. So let's just have a quick recap of what we just went through here. We just went through some of the basic terms and terminologies that come under AI. First was artificial intelligence, then was accuracy, then training data, the data that is used to train a model, and the output and the correctness of the output of that model. It's called accuracy. Machine learning, we understood that machine learning is a subset of AI. It's mainly used to predict data. A machine learning model learns on its past data. So, for example, it will keep on learning from its mistakes, learning from what you ask it. So it would keep on improving itself, mainly used for predictions. For example, you have a Tesla Roadster car and you are driving it. So while training the model, uh, it missed to identify a traffic cone. It missed to identify a pedestrian crossing the road. By giving it 5 or 10 examples of the same scenario, and by telling that what you're doing is wrong, you shouldn't do that, you should not hit a pedestrian, you should avoid hitting a pedestrian, you should avoid hitting a traffic cone. So by that process, it would train itself and it would be better than its previous version. So algorithm, we understood it's a basic part of an AI. It's a set of mathematical instructions or a set of rules that the AI model follows. And based on this algorithm, we create models. And models are characterized by the number of tokens that is used to train the model. So the latest models have more than trillions of tokens, tokens. You can approximate it as a word, as we said earlier. So generative AI, what generative AI does is the generative AI generates text, image, video, voice. And what is multimodal AI? Multimodal AI accepts image, video, voice, text as input, and it gives you output. What is NLP? NLP is natural language processing. It understands humans' language like voice to text. Let it be Siri. So that's natural language processing. What is a prompt? A prompt is a mode of interaction between human and a large language model. So how we communicate to a model is very much important. And token, we talked about token earlier. We talked about token earlier. So token. So this would be a single token. When we take these four words, the prompt would be a token. The space and ease would be a token. The space and a would be a token. The space and mode would be a token. So 1, 2, 3, and 4 tokens would be there. But if we analyze it like a human would do, we would also count the spaces. So that's how tokens work. There are also examples where a single word is divided into multiple cases when we are trying to tokenize it. So the process of converting words to tokenize is called tokenizing. So let me give you an example. Yeah, playing, PLAYING. So playing, the process of playing. So it's called play plus ing. So the word playing would be split into two tokens. It would be split into play and ing. And one another example would be unbelievable. So unbelievable would be split into un, then believe, then able. So that's how tokenization works. So all of the LLMs have token limits. So when you try to paste a large chunk of code, sometimes you may get error, token limit exceeded. So what happens is that this is how the tokens get counted, and AI agents, LLMs have a set number of tokens that can be given as input and that can be given as output. If we pass that, then it would error out. So hallucination is when AI makes mistakes. We saw one example with next year, and we saw how to fix that with prompting. We understood what fine tuning is. Fine tuning means the process of making an LLM localized on a specific subject. You're making it case or domain specific. So that's called fine tuning. This is usually done via coding, but we can achieve some part of it using prompt engineering too. So we understood what RAG is. Keep RAG in mind. We have a document tool that we use in AI Agent Studio, which works in a similar way. We understood the main parameters that should be passed using when we are using an agent or an LLM. We do not have the options to tweak these in AI Agent Studio. But if you are calling these LLMs outside of AI Agent Studio, you can use these parameters. Remember, higher temperature means more creative, lower temperature means less creative. Now, top K limits the choosing of words to the top 10 or top 50. That 50 or 10 is the K, and the top P means the probability of the sum of the probability of the words that should be chosen next. For example, let's just see the sentence that is here. So here top P instead chooses the. So next comes smallest. So what an LLM like ChatGPT does is that it goes through all of the words that has a probability to come here, and it would it would select the one with the highest probability. So we are giving it more options to select it from. So if we put the temperature as a higher value, it will not always select the one with the higher probability. It will go to the second highest or third highest or the fourth highest. So that's what happens here. So that list, we choose that list with top P. So embedding, we understood how documents, images, words are represented so that a machine or an AI can understand it. We use it, we convert it to X, Y, and Z. And more than that, I am using X, Y, and Z just for your understanding. Those coordinates, we plot it in a 3D graph, and using that graph, the similar meaning words would come together, words with similar meaning would come together, words with different meaning would be far apart. So that's what happens there. Now semantic search is when you are searching in a vector database, instead of just me pressing control F here and searching for a word, that's just querying the word, there's no meaning there. So I'll have to search for a meaning. For example, in your HR policy, your data might be structured in a different way, and the user may not ask it exactly like how it is structured in the document. The user can use his own language, but the grammar might be broken. There might be spelling mistake. So that doesn't matter. So that's what happens with semantic search.